Okay, just to wrap up, let's have a look at this worksheet here, 3.4a. Now, 3.3 didn't have section questions, and the reason for that was that 3.4 is a combined uh, set with 3.3. So the section questions for this, which tend to be a little bit more um, demanding, are found on page 143, 144. But the worksheet here does include both single displacement as well as double displacement. So let's have a look at these questions. I'm just going to give you a chance to work through some of these, and then I'll just put up the solutions, and then we'll close off the video. Okay, to make things a little bit easier here, I'm just using a short form for single replacement and double replacement. Synthesis, decomposition, and then combustion. So the first reaction is a synthesis reaction, two elements combining. Now you have to remember that these are metal and non-metal, so we're going to form an ionic compound. The crossover rule can be used to determine the chemical formula for aluminum oxide. When aluminum and oxygen react, I'm not going to provide the word equation here, but I'll just verbally share it with you. So balance reaction here for this decomposition reaction for 2 units of silver oxide producing 4 atoms of silver in the solid form, and then diatomic molecular oxygen. This next reaction is a single displacement or single replacement. What we have to do for this one is look up the activity series for halogens. So go back here and we find that bromine is more active than iodine. It's higher in the activity series. So here's bromine. It will displace iodine from a compound. So if we return to other slide there, we would find that a reaction is predicted here. You do have to keep those things in mind. You will be expected to use tables and charts to write a reaction equation that's informed, not just theoretical. So balancing that, bromine, molecular bromine is a liquid, 2 units of potassium iodide forming 2 units of potassium bromide, which are aqueous. Can you check your solubility chart for that? And molecular iodine, which is a solid in its standard state. The next reaction is also single replacement. Zinc is an active metal and is more active than copper. We can again refer back to our chart here. The location of zinc relative to copper, it's higher by quite a few elements, so it will kick out or displace copper. From this reaction, the nitrate is highly soluble in the presence of copper, so looking at our solubility rules, we can predict that that would be aqueous. We're told it's a solution, so we can also confirm that though with the solubility chart. And this is a 1-to-1 ratio of ions in all cases because copper and zinc have the same valence at 2+. 2 nitrate ions are needed for each of those compounds to form, so the predicted product would be the spectator group zinc nitrate, which would be fully soluble, and the copper metal, which would be obviously atomic element in its standard state. Next reaction here is double replacement, combining soluble barium chloride, soluble sodium sulfate, forming barium sulfate, which has low solubility, and 2 units of sodium chloride for balancing, which has high solubility. Sulfuric acid, which is a pure form in its liquid state, is also called aqueous hydrogen sulfate, but in this case it's a liquid. You can look that up under common chemicals in the appendix. Combine that with aqueous sodium hydroxide, which has high solubility, forming, in this case this is a double replacement, but it's more of an acid-base type reaction, so water and a salt are the products. So 2 units of molecular water and sodium sulfate, the highly soluble product, would be predicted. So no precipitate from that reaction, but we would get liquid and a salt. Copper 2 acetate and sodium sulfide are the 2 reactants here. Both have high solubility. We can verify that solubility table. Again, sulfide is one we hadn't looked at yet, but sulfide is highly soluble with group 1, group 2 cations and ammonium. And you'll start to notice here that group 1 appears lots in the highly soluble category. So returning here to our slide, we go back and see that the products here are already provided for us. Copper sulfide, copper 2 sulfide rather, which has low solubility, It's not ammonium, it's not group 1, it's not group 2. It's in that low solubility. It'll be a precipitate expected, and 2 units of sodium acetate, which have high solubility. The next reaction is single replacement, copper 2 sulfide reacting with oxygen, forming elemental sulfur, which you may have recalled at the beginning of the course. We looked at this as being an octahedral element. So it's sort of a molecule in its element form. And in this case, copper 2 oxide would be the other predicted product. And copper 2 oxide, if we're looking for the solubility of that, we probably won't find it because we don't see oxides in this chart. So we'll just predict that we will get solid products in both cases. So that's single replacement. Almost done here. Looking at the combustion of propane. So this is a combustion reaction. Propane, you can look up in the common chemical table. C3H8, it's a gas. Combining that with oxygen, we get carbon dioxide and water. It's not yet balanced. I'll leave that one for you to figure out. Final reaction is more or less a double replacement reaction. It's a little different because when sodium and hydrogen switch places, the product hydrogen carbonate actually decomposes pretty quickly into water and carbon dioxide. So carbonic acid, or aqueous hydrogen carbonate, is what's used to carbonate soft drinks, and that decomposes into CO2 and water. So it does fit the double replacement category, and aqueous sodium chloride would be the product. This is also a little bit more like an acid-base type double replacement because the reactant sodium carbonate is a weak base and hydrogen chloride is a strong acid. So for the assigned questions in this set, I'll refer you back to the previous piece of paper where we looked at a couple of examples using your solubility chart. There's some work we can do in class now that you've viewed this video with a partner, and then independently some questions that look at double replacement, as well as some that have you go back and review the sections on single and double replacement on page 143. See you in class tomorrow.